Okay, so we started talking about the binary stuff. Let's now look at hexadecimal. And we talk about hexadecimal and octal. If you think about hexadecimal, first of all, hexadecimal is 16. We think hexa meaning 6, decimal meaning 10, and octal is 8. Well, if we think about these are both powers of 2. 2 to the 4th power and 2 to the 3rd power. And let's talk first of all what hexadecimal and octal would be used for. Mainly when a computer thinks about it, if you think about a bunch of zeros and ones, the computer's going to take a ton of space to record a bunch of zeros and ones. Well, what it does is, for simplicity's sake, it actually takes the numbers and shrinks them down, because if you take a number like 1001 in binary that's 4 digits long, now mind you, this is 2 to the 4th power, I can easily take these 4 digits and turn them into one character in hexadecimal. Since octal is 2 to the 3rd power, if I had a number like this in binary, I could turn this into one character in octal. And we're going to focus on that a little bit later once we figure out what hexadecimal is and how it works. So if we look at hexadecimal, the first thing we have to remember is, like we talked about binary, we actually ran out of characters before we got to 9. In hexadecimal, it actually, since it talks about 16 characters, we have to go from 0 all the way up to 15, which means we have to introduce letters. If you ever think about an error that you've gotten in the computer sometimes, you may have seen the letters in there and you were confused by what it was. It's because the computer was writing in hexadecimal. So let's look at some numbers here and let's figure out what we're doing when we talk about hexadecimal. Well, first of all, if I want to take a number like 235, and that's in base 10, that's in our decimal places, and I want to start to look at this and I want to say, okay, what would this be in, first of all, let's focus on binary first. So what would this be in binary? Well, in binary, we know that we're talking about 2 to the 0 power, 2 to the 1st, 2 to the 2nd, and all the numbers that are powers of 2. Well, this is 128, and clearly there's a 128 in 235. So that's the first thing that I do. Subtract that out, I get 107. I know that I need a 128. 2 to the 4th is 64. There's definitely a 64 in there. Leaves me with 43. There's a 32 in there. There's not a 16, so I don't need a 16. There is an 8, so I need that location. There's not a 4, but there is a 2 and there is a 1. So if we talk about this in binary, I need a number, we've talked about all 8 locations here. When we talk about a byte, I need something in the 128 location, in the 64 location, in the 32. I don't need anything for 16. An 8, no 4s, a 2, and a 1. So 235 in decimal would be that number in binary. So a quick review for us. But what if we wanted to look at this number right here, 235? What if we wanted to look at it not in binary, but if we wanted to shrink it down to hexadecimal? Well, here's what we would do. First of all, if we take it down to binary first, we can look at 4 chunks at a time. So I can look at this as 1101, and I can say, okay, well, what is this in binary? I'm sorry, what is this in hexadecimal? Well, in decimal, this would represent the number 14, which means in hexadecimal, this can be represented by the number E. If I look at this part here, the 1011, well, this represents the number, this is an 8, this is a 2, and this is a 1. So this represents the number 11 in decimal, which is a B. So this number, 235 base 10, or 1011101011 in binary, would be in hexadecimal, would be the number EB. Let's look at one more example. Let's say we are looking at this number in binary. Well, I chunked it into 4 sections already. And we're going to take those 4 and we're going to make this into hexadecimal. So in this particular case, I have this 1 here represents an 8. This 1 represents a 1. So this would be 9 in decimal, which is also 9 in hexadecimal, because we can use that character. I have a 4 and a 2 here, which is 6. So far, the decimal and the hexadecimal look the same. But now here, I have an 8, a 4, and a 1. So it's going to give me 13. Well, if you think back, 10 is A, 11 is B, 12 is C, 13 is D. So this would represent this binary number and this hexadecimal number are exactly the same. The way a computer would use this, instead of having to hold 12 characters, it actually can shrink it down for storage purposes and only focus on just holding 3 characters. And that's one of the main reasons we use hexadecimal. So we can go from decimal to binary, which is usually the easiest way to do it. And then from binary, we can go to decimal. We can also go to octal. So if we focus on that same number, but now what I'm going to do is I'm going to chunk it by 3s. And I think octal. Well, in octal, this right here is number 4 and 1, so this is a 5. This is also a 5. This is also a 5. And this is a 4. So that number right here, we have it in hexadecimal. Right here, I have it in octal. If you get a number, let's say we're looking at 1 byte, and I want to put this into octal. Focus first of all on the back. Start on the right-hand side and work backwards, opposite to what we're used to in this country. This is a 6. 101 is represented by 5. If you need a number, put the number in front. Give yourself that third set. And this would be 256 in octal. I'm going to give you some practice questions with this. Let me know what we think. I'll put another video up later.